he's not here, so that's why I invite the second presentation. Mind the Gap, dual knowledge graph framework for unified multitask user intent inference. Please come. Yeah.
Good afternoon, everyone. My name is Tzu-Cheng Peng, and you can call me Ian, and I'm from National Taiwan University. And one of my co-authors is also from National Taiwan University, and one of is from University of North Texas, and one of them is from Taipei Medical University. I'm very happy to be here to present our work, Mind the Gap, a dual knowledge graph framework for unified multi-task user intent inference. And here's my outlines. This presentation is organized into 6 parts. The first part, I'm gonna introduce our motivation and explain why we think user intent is very important. In part 2, I will give you our problem framing, and in part 3, I will introduce our core idea. In part 4, I will walk through our whole framework and some key component with you. In part 5, I will describe our data set and show you our final result. Finally, I will conclude with some takeaways and some case studies. Alright, first of all, why user intent matters? We have found that many of travel platforms like TripAdvisor or Trip.com accumulate massive user-generated hotel reviews. Like this picture, this is a screenshot of the on TripAdvisor. As you can see, this is Pullman, Jakarta, Indonesia. It's where we visited. And there is 4 reviews. And we think that these reviews reveal more than satisfaction. That means that implies more than user expectations and their priorities. And this intent understanding not only supports personalization, but also recommendation and service intelligence. The challenge of this kind of understanding is that this intent is often implicit and contextual and more closely tied to the user experience. Right. So our problem framing is that from reviews to latent expectations, more formally, we are doing the reverse intent inference. That means we are doing reconstruct expectations from post-consumption reviews. And here's an example. This is the review the user left on the travel platform. It says, the room was quiet, the Wi-Fi was reliable, and the hotel was close to the convention center. In our assumption, we think this user might be think that he needs a quiet room in this hotel, and this hotel must have a reliable Wi-Fi, and most importantly, this hotel's location must be nearby the convention center. Alright, but what is missing about this research? We point out 2 points. The first of all is hierarchical pipeline can propagate errors. In fact, this hierarchical pipeline is our previous work, and we think there are still some limitations need to address. And the second one is the standard rank process that needs some structural relationships. But based on these limitations, we asked 2 questions in this research. The first is, can dual knowledge graph augmentations improve unified multi-task intent inference? The second question is that does structure-aware alignment outperform the traditional text retrieval? To answer these 2 questions, we have the core idea is we are going to build a dual knowledge graph grounding. We separate the knowledge into 2 complementary graphs. The first one is user intent knowledge graph. This knowledge graph can represent the user's preference and its sentiment. So we think it is the review-specific knowledge graph. The other one is global hotels knowledge graph. This knowledge graph is constructed on all hotels information. So we think it is the domain-level knowledge graph. So we align with them and doing a grounded intent prediction and generation at the same time. To simply say, when the framework separates subjective user semantics from stable hotel domain knowledge, then we are going to align them during the inference stage. So here's our whole framework. We call that as a DKG-MTI, which is dual knowledge graph multi-task intent inference. Too long. It consists of 4 steps. The first one is dynamic user knowledge graph construction. In this step, our system will extract the review-specific semantic triplet from the original reviews. And then we're gonna use this extracted triplets into the second step. We're gonna use this triplet to retrieve relevant global hotel knowledge entities by cross-graph alignment. In third step, we're going to do the semantic smoothing. That means we're gonna use local graph context to refine the meaning of our extracted triplets. And finally, the fourth step, we're gonna do the unified inferences. In this step, our system will finally predict the ratings of this review and generate the reverse intent at the same time. Right, this slide shows how we construct the global hotel knowledge graph. In our left side is the screenshot from the TripAdvisor. It shows the hotel's information, like what's the aspect rating is this hotel staff and property amenities, the room features and room types of this hotel. This knowledge graph represents the stale hotel related entities and relationship. We define 6 node types, includes hotels, facilities, or room types, location, travel types, and aspect. And we got more than 15,000 of the nodes. Our relations include has facility, located in, and prefers. And more than that, I'm not showing on this slide because I have no space on this slide. So overall, this knowledge graph provides structured grounding beyond the raw text retrieval. And here is our example of our knowledge graph. As you can see, maybe it's not so clear. The yellow one is represent the hotel, and the pink one represent what the facilities these hotels have. For example, these hotels have a gym, has breakfast service, and has a pool. And the brown line it indicates that this hotel has the reliable Wi-Fi and air conditioning. Next is how we construct the user intent knowledge graph. And this knowledge graph is constructed for each individual review, and it can extract the semantic triplet from review narratives. Most importantly, this knowledge graph can capture subjective preference, sentiment, and experiential signals. So by doing so, it can transform text into the explicit relational structure. For example, this is an example review. It says, the room was quite small, which made the stay less comfortable than expected. However, I really value the quiet environment, especially at night. As I needed to work during the trip, reliable Wi-Fi was very important, and the connection was stable throughout my stay. And our system will extract some triplet from this review. We have the 3 examples. The first one is user dislikes small room. As the first sentence says the room was quite small, so our system will think that this user disliked the small room. And the second one is user value the quiet environment. And the third one is user needed a reliable Wi-Fi. Both of them are mentioned on this review. Right. So far, I introduced 2 graphs, but how we align them. If we just use lexical similarity, may miss some contextual meaning. And what is that means, right? A node like service, I'm going to take service as an example, will be changed the meaning across the local context. If the service in the sentence, it connects the restaurant, maybe this service indicates the dining service. If the service connected to some check-in, maybe its service is indicated to a front desk service, right? So we applied semantic smoothing by incorporated these neighboring nodes into representations. After smoothing, these smooth nodes will retrieve more relevant global entities from this knowledge graph. Like the example we just got, user dislikes the small room. This small room will be extended to the room size, the room type, and comfort. Like the quiet environment will be extended to sleep quality or noise level. This is what the hotel knowledge graph got. So the final step is unified multi-text intent inference. In this step, we're going to use the large language model to perform classification text and generation text at the same time. And this system's input combines the original review with just the raw text and applied contextual knowledge as I just explained. So we have 2 texts. The first one is just as I say, we have the classification text. It predicts 6 level ratings. We have value, location, rooms, service, sleep quality, and cleanliness. And the second text is the reverse intent generation. It means we're gonna generate a first-person reverse intent statement. Like, I need a quiet hotel with a reliable Wi-Fi for this business trip. Alright. So here's our description of our data set. We collect 10,000 reviews from a TripAdvisor, and all these reviews are rotated by English. And it consists of 745 hotels. And as I said, we have 2 tags, and we use 7 baseline to evaluate our method's performance. The first result is aspect rating prediction. We got overall macro F1 score increased by 13% compared to our base model, which is Llama 3.18 billions. And this radar graph, our model is the yellow one. As you can see, we are relatively the best. We got the value 0.88, and location we got 0.91, rooms got 0.80, service got 0.81, something like that. Right. The second result is reverse intent reconstruction. In this text, we use 3 metrics to evaluate this text. The blue and the rouge we got is evaluate how accurate is the wording of the LLM's output. And LLM as a judge, this metrics is to evaluate how accurate is the meaning of the LLM's output. So again, as you can see in our performance table, we are also relatively the best of over these all 7 baselines. Okay, we have also done some application study, and our finding is that every time we remove a component, the performance will be just dropped down on both classification and generation tags. Alright, finally, let's take a look at our case study. And here's the user review. I think it is relatively small, so let me just read for you. Stayed here for a 3-day conference. The location was perfect, just a short walk to a convention center. The room itself was clean and modern. Though a bit of small side, the real lifesaver was free and high-speed Wi-Fi, which was crucial for getting work done in the evenings. The breakfast buffet was decent, but the hotel bar was always too crowded and loud for a quiet drink after a long day. And this reveals one truth is that I am a business traveler looking for a hotel with excellent connectivity and quiet atmosphere, conveniently located nearby the convention center. So you can imagine that this review is focused on business travel and the location and the quiet environment and, as I said, the reliable Wi-Fi. So here's our compare method. You can see bottom of the 3. And Llama 3.18 billions and 9th grade. Although they are captured the hotel's location and the breakfast service, but they are missed the business context. And this one is called high KG, which is our previous work. It's all distracted by the danger, and I don't know why it's all wrong. But our method can better capture the hotel's location and reliable Wi-Fi, quiet environment, so that the keywords. So quickly to conclude our work, we propose the DKG MTI, which is dual knowledge graph, a multi-text intent inference, a dual knowledge graph grounding without text-specific fine-tuning, and we use structure-aware alignment between user intent knowledge graph and global hotel knowledge graph. And this unified multi-text framework, it could predict the rating and the intent generation at the same time. Alright. Since we are planning to use this reverse intention as a foundation for our future work, we're gonna build the recommendation systems. I would greatly appreciate any feedback or suggestions from you. And this is my presentation. Thank you very much.
Thank you, Ian. Thank you very much for the presentation. I think it's very interesting and very